This is Sydney speaking, and today's webinar, as you all know, will be starting with a sneak preview of SolidCAM 2016, and this will be in a series of different webinars. Now, before I actually start speaking, Emil would like to say a few words, so I will make Emil the presenter, and then we can get started. Okay, Emil, you can go ahead.
Hello, everybody. Welcome to the first webinar on SolidCAM 2016. This is really one of our very important versions because we have done a completely new, I would say, approach to advanced mill turn to make it easier to support these complicated machines, both from the point of view of the work of the customer on the software and from the point of view of supporting the post-processor. Sydney today is starting with the first webinar on our subject, not related to mill turn, but we plan to give a series of 3 webinars on this subject. The webinars are planned by our product manager for mill turn, Michael Binetsky. We will have 3 webinars, as I said, 2 webinars to explain how to work in the software, and 1 webinar that explains the new changes in the BMID and how it affects the post-processors. And I really recommend to everybody to join these next 3 webinars. It will not start next week, but the week after. Next week we will not have a webinar, because it's very important that we explain to you all the intricacies of this new version. That will be really great for the customers, for you, and for the postal writers. Actually, Michael wants really to transfer all this information in the best way, and I could tell you right now we have in our office Stanislav Baprik from the Czech Republic, who is one of the advanced postal writers, and he's getting instruction directly from Michael, but obviously we cannot give it to each of you personally, so join those webinars and you will get great information on our advanced mill turn. Another point I want to remind everybody, you know, we have a reseller area in our new website, and since you are having these days these SolidWorks 2016 events, we have put for you inside this reseller area a version of re-release version of SolidCAM 2016, and we have put also demonstration parts that you can use to demonstrate the software. 3 very nice mill turn parts, and also you could obviously use this pre-release to check the software. We'll be updating this pre-release as we have new versions. So Sydney, go ahead and show us the first webinar on SolidCAM 2016.
Okay, thank you very much, Emil. Okay, so let's get started. What I'll be concentrating in this particular webinar are some of the new options that we have inside milling, whether it be 2.5D milling, creating chain geometries, some of the compensation issues that we have, and one of our more powerful options that we've added inside SolidCAM 2016 of transformation. So let's actually get started. Now we'll start with our 2.5D milling. Now, one of the things we've added inside our profile operation is the capability of having compensation. Excuse me, for having compensation on our rough passes as well as our compensation for finished passes. And when using clear offset, you can also have compensation on our clear offset. Now, in addition to this, we've also added something new called combine and floor finish passes. Combined wall and floor finish passes allows you to actually do only a finished pass on the floor at the very end if your tool is large enough to cover the entire floor. And we'll see exactly what I'm talking about in the part that I'm about to show you. Okay, let's first get started. And what I'm going to be doing in this particular part is I'd like to mill out this step over here. Okay, now the width of this step, for your information, is a total of 15 millimeters. Now let's go into the operation itself, and we'll go into our technology, into our tool. Sorry, my tool that I'll be using is a 16 millimeter end mill. Now 16 millimeters is enough to cover the entire floor over here, but if you were to do that with a rough cut, you would actually be using almost the full diameter of the tool, which is not always the best idea. But before I talk about the clear offset and everything else like that, let's go into our technology. And as you can see in our technology, we now have the option of compensation on finished passes only. And if I'm using rough, you can see that I have the option of putting the compensation in our rough as well. So I can have it both in rough and in finished. Let's first take a look quickly at the G code without the compensation on rough passes. And you'll see that in the very beginning, the first passes does not have your compensation, G41. Okay? But as I go further down to my finished pass, we have here G41 for our finished pass. Now, if I have to go back here and change this and add compensation on rough passes, just a moment. Okay, if I were to change compensation for rough passes, let's take a look at the G code now, and you'll see already in the very beginning, even on our rough passes, we'll have our compensation as well. Okay, and you can see that all the way down the line. Now, let's go a little further. In this particular case, I want to use my clear offset. Okay, I'm going to have a clear offset of 8 millimeters, an offset of 8 millimeters, stepping over 7.5 millimeters with a 0.5 wall offset. Okay, now, doing that, you'll note that I also have the option of doing compensation on the clear offset passes. Let's first take a look without the compensation on the clear offset passes, and you'll see G41 does not kick in, only at the very last rough cut. Now, if I were to put my compensation on clear offset as well, it'll already start at the very beginning. So we've actually have now complete control of where we want to have our compensation. You can have it on all the passes or just some of the passes, exactly the way you want it. Okay. Now, let's talk about the option of combine and wall floor finish passes. Right now, it's grayed out because I have no floor offset. So it's always going to go directly to the floor. However, let's put in a clear offset from the floor. Sorry. There we go. And you'll note now that we have an option of combine wall and floor finish passes. Let's see exactly what this does. First of all, I'm not going to check this. And we'll take a look at the simulation, what happens if I don't use this option. We'll do save and calculate and simulate. And let's run our solid verify. We'll take a look also at the same time at our Z level as we go down. Okay, so let's do this one step at a time. You'll see we have our first pass, second pass. Now we've gone down to 24 millimeters, and our last pass is at 29.5 millimeters. Well, Actually, I did say last pass, but this is the last pass on that area. Now it's doing the finish cut already for this particular step. And there we have our finish cut. Now it's going to go back up, do our next step, and do the same thing again. 29.5, and then do our finish cut. So we've already had 2 finish cuts over there. Do the same thing here. That's our finish cut at the very end. Again, going down to that. So we actually, on the floor, we had 3 passes just on the finish over here. But you know what? For finishing it, all I really need is just 1 pass. So what I can do here is as follows. I can do combine wall and floor finish passes. This is good when I have my tool can cover the entire step. Let's take a look at how this looks now. You'll see as we go down, we have our first pass, second pass, third pass at minus 24, and our fourth pass at 29.5. It finished that pass. Now it's going to go over to the next area. Notice it did not finish the floor yet. Same thing over here, 29.5. Now it's going to do our finish pass on the wall and on the floor, finishing off the floor. In other words, we had on the floor itself only 1 pass, making also for a very smooth surface on the bottom without the running into the problem of sometimes having a line from that first finish pass that we had over there. Okay. Now let's continue on further into our webinar itself. Okay. Just a moment. There we go. We've made an improvement in our pocket recognition by adding the option to limit the depth of cutting in pocket recognition operation. In other words, we've added something called lower level. This was not here at all before. Whenever you did pocket recognition beforehand, it always did it from whatever your upper level was all the way down to the very end. So if you were working with a short tool, in other words, a tool that was not sticking out of the holder enough, you were not able to use pocket recognition because then you would run the risk of having the holder actually crash into the part itself because you cannot limit the depth. Now we've added the option of lower level so you can actually use shorter end mills to limit the depth only to a specific area without worrying about going down too far and hitting the holder into the part itself. Let's actually take a look at how this works. I'm going to load a new part. We'll close this one. And we'll go into a part for pocket recognition. Okay. I'm going to start the option of pocket recognition. And let's create the geometry. We'll just click on the part. As it's recognizing the entire, all the surfaces, all the open pockets, all of this is recognized. Okay, that's good so far. Next, I'm going to go into modify because I don't want to do the top surface. I'll get rid of exclude top faces. Now let's choose our tool. The tool that I'm going to start out with is a 16 millimeter end mill. That's outside of the holder, a total of 45 millimeters. Okay, and I'll select that tool. Now, if I go to my levels, you'll note that my lower level is at minus 80. Well, minus 80 with a 45 millimeter outside of the holder you can be sure that it'll actually gouge the part. The holder will gouge the part. So what we're going to do is actually limit our lower level, and I'll limit it to this surface over here, minus 40. So now we can use that shorter tool in pocket recognition. As far as our technology goes, we have the same options that we had before, so I'm going to set that up. We have our links. Everything is just the way we had it before. So let's just do save and calculate, and we'll run our simulation. You can already see, by the way, on our tool pass that it's only going down to this level over here. We'll take a look at the Solid Verify, and you'll see it's machining everything that needs to be machined up until this level, including inside the holes, only up until that level. Now, to continue on down, here I have no choice. I have to use that longer tool. So I'm just going to do save and copy. And now I'm going to change it to a longer end mill outside by 85 millimeters. In my levels, my upper level will be this surface over here, whereas my lower level would be that very bottom over there. We'll do save and calculate again. Again, run my simulation. And now you'll see that's only working in those areas. Notice it continued down from that depth to the very bottom. So now, in our pocket recognition, since we're able to limit the depth, we can work with tools. We don't always have to work with tools that are that long for this in part. We can first start out with shorter tools, and only towards the end go to the longer tools. Okay, let's now continue further into our webinar, and let's talk about geometries. We've made a major enhancement in how we choose our geometries. First of all, even before choosing them, you can now see the actual chain that you're creating on the very top plane of the part, making it easier to visualize exactly where you're working. Okay. Now, in addition, we've also cleaned up this entire area. Note what's not there anymore. We don't have anymore the option of automatic general or automatic constant Z. All we have is curve. And inside curve, we've added the option of working with either tangent propagation and constant Z propagation, and the delta Z is automatically there together with the constant Z propagation. Okay? Now, we've also had that the defaults actually come out looking like this. Now, I said something about the defaults, but in a moment, I'll show you one more thing before I talk about the defaults. You'll also note that in our control buttons that we have in the side window over here, we've added 2 control buttons. You'll see in a moment that after I pick a specific edge, it'll ask me if I'm not using the tangent propagation or constant Z, or it doesn't meet these standards, which direction do I want to go to? And it'll give me a default direction, but it'll show me what else I can do. Note we have a default direction with the arrow. We have a button here which is for continuing the automatic selection process by choosing the selected element, okay, which is the one with the arrow. If I want to change direction, I can change direction with this button. Let's see exactly how that works in a moment, but one more thing about our defaults. Now, not everyone will agree that they want to always start out working with this as my default setting. So we have in our SolidCAM settings the option of setting up exactly how do I want my default to start when I start my creating my chain geometry. We have it separate for milling and separate for turning. Let's take a look now exactly how all of this works. We'll go out of here and we'll load a different part. Now, let's take a look at creating a geometry. First of all, we'll start up by wanting to create a geometry around the entire part. Okay, so let's take the option of, say, profile, and we'll go to geometry, create geometry. Note exactly how this looks now. Okay, we have show chain on work plane, and we have our curve where tangent propagation and constant z propagation is automatically checked as well. I'm going to click on this edge over here. Note what happens. It picked this all the way going up over here up until this point. And you can also see it projected on the very top. Now, starting off over here, it went constant z. When it got over here, it went to z tangent propagation. Over here, it had another tangent propagation, so continue z, so continue over here. This was constant z, and tangent propagation. When it got over here, it's not constant z anymore, and there's no tangent propagation. But it's showing you what are the options. Now, I can pick it directly from the part, and if I click on the edge over here, it'll close the chain. Now, let me do this again now. I'm going to delete what I did over here and start again. This time, however, I'm going to get rid of the tangent propagation and the constant z propagation. I'll start by picking this edge. Note, we see it on top over here as well. And when it gets here, it shows us, okay, what are my options? To go in this way, to go up here, to go along over here, or to go down over there. I can start picking, but you know what? Let's see exactly what these buttons over here do. Okay? This is what I mentioned before, change direction. Now, if I click on change direction, take a look at the arrow. It's showing us which what are my possible directions. This is the direction I want to go into right now. Now, I can go ahead and start clicking over here, but let's actually use now this little button that I have on top over here, which says Add Selected Element. I'll click on that. You'll see it's starting to move forward. I just keep on clicking, and it keeps on moving on my part. And you can see, according to direction, where it's going to be going. Go over here, go over there. We'll go over here as well. Now, when it got to here, it wants to work its way in. I'll just change direction, go over here, and there we have it. I have an entire chain without ever touching any of these edges, just by controlling it from over here. Now, I'm going to load a different part and show you where that actually comes in very handy. Okay, but before I do that, I also want to show you in our geometry defaults, I'm going to get rid of this so we can see how it looks without that option over there as a default. Okay, we'll start the next part, and this is a little more complicated. I'd like to create a chain geometry along the top edges over here. None of these are constant z, and none of these are tangent propagation. And you'll note we have lines over here, we have a small one over there. So let's actually start creating the geometry. We'll go over here. You'll note my defaults are turned off, and I'm going to start over here with this line over here. Okay? Now, the way you used to work was come here, then click on this, then look for this one over here. Then wait a second, let's zoom in over here. Click on that one. Wait, let's click on this one, this one, this one. You know, I would have to go to each one, start zooming into those really small ones. In other words, it would be pretty, missed that. In other words, you see how much work I have to do in order to create this geometry. Let's now do it again, and we'll do it a little differently. I'm going to start exactly the way I started before, but instead of clicking on the lines, I'm just going to work over here. Add selected element. And look how quickly I'm adding my chain. Without having to zoom in to pick any lines, I'm just going around the part, and there is my chain. So this is a very powerful selection tool for our chain geometries. Okay, now there's one more part I'd like to show you. We'll close, that has to do with geometries. Okay, what I'd like to do in this part is to mill out these steps over here. So my chain geometry in this particular case has to be this first one over here, then another chain over here, another chain over here, and then another chain over here. So the way everyone knows how to do that is we'll come over here, we'll click over here, and then I'll move my mouse over to here and accept it. Move my mouse back to here, then move my mouse back to accept chain over here. Again, back to the part, back to the window, back to the part, back to the window. In other words, I'm going back and forth all the time. I've had customers that actually I've gone to them, and the fact that they move back and forth so much, their table is all worn out from their mouse area just because of moving back and forth so much. So what I've done here is actually created a new option that will eliminate the need to always going back to the accept chain button. Let's see exactly how I can do this. Well, everyone on their computer has a button on their on their keyboard that looks like this. It's called a control button. Okay? So what I'm going to do is we're going to make use of this control button. What I'm going to do to start my geometry is first click on this edge over here. Now I'm going to go to my control button on my keyboard. I'm holding my control button now, and I did this. Now I'm going to go here and click on that edge. Note what happened. Our first chain was automatically accepted, and we had started a new chain. This is just by holding my control button down. I'm still holding my control button down and clicking on this edge. Now I have another chain. The same thing here. Holding my control. I have another edge. Now that I'm finally finished and I have all the chains I want, I'll just accept at the very last chain, and there we have 4 chains without having to go back to accept chain every single time. Okay. Now let's get back. Let's go further down now in our webinar. Let's talk about transformation. We've added new functionalities inside our transformation to make it easier to do transform or give it more possibilities. Say, for example, I can actually do a transform, translate, I should say, according to the direction of a specific coordinate system. For example, we'll see this in a few moments. I have these two holes over here. And I've done this hole using this position over here. Okay? Now I want to transform that operation to here. But what I can do right now is I can say, okay, we're going to transform it, but using the direction of this Mac over here. This can also be done without another Mac option. This can also be done by choosing a specific vector. In other words, transform in a specific vector direction. Let's take a look at what this actually does, how this actually works. We'll close this part. And I'm going to open up this particular part as we see over here. Okay? Now, let's take a look at this operation over here. I've actually drilled a hole in this over here. Okay? Now, I'd like to drill this hole also over here without creating another operation, but just simply by transforming it. But I'd like to transform it in a specific direction. Okay. Note I'm in Mac 1 position 4. Let's go into the operation itself, and we'll go to transform. We'll choose the option of translate matrix, and note we have the following. We have the traditional way of doing it exactly in XY only. XY only would not be good because then it will go only in the X direction and the Y direction. Or I can do it by a specific coordinate system. Now, right now you can see it's according to Mac 1 position 4, which is the position I'm in. You can see that over here. I can change that by using a different one. Now, I happen to know that Mac 1 3 is the one that I need. Now I can also change the direction I want it to go. As you can see, we can do it either in ZX, YZ, but in this particular case, I want XY. Okay? Excuse me. So you can see that this is now the direction it's going to go in. And I want 2 copies at a distance of 105 millimeters. Okay? And you'll see it go directly to that point. Let's run my simulation. And you'll see the tool goes down into the first hole, starting at the proper depth. Sorry, my mistake. Do it again. It comes down to the first hole, starting exactly where it's supposed to. When it finishes this hole, now it'll come down exactly to where it's supposed to start on this hole over here as well, and then drill out that hole. Now, I don't have to do it according to Mac position. I can also do it a little differently. Let's go back into here. Okay? And instead of Mac doing it according to a Mac position, let's do it according to a specific vector. Okay? And I'm going to choose the vector. I'd like to have it go according to this particular line. In this particular case, I have a line here that's going in the direction that I need, so I can use that. So let's go and choose that line, accept it, and as you can see, it's going exactly the way I want it to go. Two copies in that direction, and a total of 105 millimeters. And again, if I run my simulation, you'll see that the exact same thing happened. Goes down and then over to the next hole. Now, one more option I'd like to show you, which is a little bit of a surprise to everybody. We have a new way, or I should say we have now a new way of doing a mirror operation. Okay? For example, if we take a look over here, I'm milling out a profile around these three parts, and I'd like to do a mirror around these three parts. However, when I do the mirror, I'd like to keep the exact same cutting direction. So if I'm working climb milling over here, I'd like to have it also climb milling over here. In other words, keeping the same cutting direction. Now, up until now, we were not able to do that. We had, whenever you did a mirror, it also flipped the direction of your cutting. If I did climb milling, it did conventional milling. Let's take a look exactly what happens now if I want to do it. First of all, I'll right-click on the operation, and we'll go to the option below transform. We've added a new mirror option. Now, I can do it around a Mac position over here. In this particular case, it happens to be sitting in the middle. Or I can even do it according to a selected plane. In other words, if I have a plane going through the part, I can do it according to that plane. You know what? Let's do it according to plane. By the way, before I do that, as you see, I'm doing Mac 1 position 1. We have here showing us which direction I want to have the mirror. Around this, or do I want to have it around the ZX, YZ, or XY? In this particular case, it would be YZ. I can also go, as I said now, to selected plane. And if I go to choose the plane, I believe in my list down at the bottom, I created a plane that was exactly in the middle, and I can use that. Okay? Now you see it's going to go in this direction. You click on OK, and if I go into the operation, you'll note it created a new operation. This is important because it allows us, in this particular operation also, to choose different parameters. For example, if I take a look at the toolpath, it's actually starting out over here. I want it to start out over here. So I can go separately in my technology, go into modify geometry, and say, you know what? My start position, I want to have a 0 shift on all of the chains. And you can see it all moved over there. Now, let's take a look at the cutting direction. You'll see the cutting direction is going, it went climb milling. Okay? Let's do, again, simulation. This time we'll simulate both the first and the second. And you'll see in the first one is doing the climb milling once on that wall, around the part, and then out. Now when it comes to the other side, it'll continue working, this time climb cutting as well. So now that long-awaited option of being able to do mirror with keeping the direction, your cutting direction, is now available in 2016. Okay, let's just go a little further down the line, and let's just show, I have 2 more points I'd like to bring out. One, in our integration into SolidWorks, we've actually taken the new milling part dialog window that we had always that popped up in front of the part and moved it now to the SolidWorks dialog at the side. So your part will always be available. In addition to this, we've also added in our CAM tree the option of showing the machine time of each individual operation. So you don't have to go and do simulate in order to see the machine time. You can actually see it inside your CAM tree. Let's take a look at this. First of all, let me load the previous part. I'll actually load this part over here. Note in the right-hand corner, we see the actual time of the part, of each operation. Okay? Now, this can be turned on or off. If I were to right-click an operation and go to CAM tree view, we can hide machining time. Now you don't see it. Go back, CAM tree view, show machining time. Now we can also have this as our default that will always show the time. That if I go into my CAM settings, we have default CAM tree, we have show machining time. You can see it's checked off in my particular case. Okay. Now the last thing I just wanted to show you is what I mentioned before about the dialog. I'm just going to load, I'll just load a part over here. And I'm going to start a new project. Note when I start my milling, you see now that this particular window is in my left-hand side, just like as it was in SolidWorks. Okay, so you see it now fully integrated into SolidWorks. Now let's continue on down because there's more than just this window. Just a moment. Okay, there's more than just that window. Let's create my coordinate system. And I'll click on this surface over here just to create a home position, and I'll accept that. Note what we have here. Also, this particular dialog window of the tool level, the tool start levels, clearance level, is also now inside our SolidWorks dialog on the left-hand side. It's not covering the part anymore. All is exactly now more integrated into SolidWorks. Okay, that is basically what I wanted to show you in this particular webinar. Excuse me. Now, just to let everyone know, a lot of these changes that we have, or these additions that we have in the programs, comes from customers, comes from our resellers. People tell us, look, we need to add certain functionalities, and over the years, that's how we keep on improving our program. Keeping in touch with the customers always helps us be dynamic and always improve according to our customers' needs. And this is exactly what we're doing whenever we see anything coming up new in our program to make things work a lot easier and a lot clearer. Okay, I'd like to thank everyone for joining us in our webinar. I don't see any questions at this point, but this webinar has been recorded, and you'll be able to see this webinar, the recorded version, in our website. If I were to go into our website, you'll be able to see this webinar. Just a moment. I'll show you exactly where in the website the resellers can see this. I'll just log in. And if I were to go into company reseller area, we have here reseller webinars. So the webinars that we have for the resellers will be listed, will be shown over here. Right now we have last week's webinar, but in the future you'll also see our older webinars as here as well, which are very informative to you, that you'll always need, you can use for reference. So this webinar that I've done today, you'll find it in this area of the resellers area. Okay. Question was asked, what version are you using? I'm using SolidCAM 2016 together with SolidWorks 2016. As far as the icons goes, we are making new icons for SolidCAM, which will correspond to the way SolidWorks does their icons also. As far as mirror in the 5-axis operations, I can't answer you for that right now. As far as index seal, yes. Okay, that's it for the webinar now. Everyone take care. Have a great weekend. And we'll see you in 2 weeks in our next webinar. Bye-bye now.